Hey everybody, before watching this video, you should definitely watch the first video featuring Grant on factoring. Yes, I know it's long, but it really does cover all that you need to know about factoring. I wanted to address specifically the factoring of trinomials that have leading coefficients that are not one. In Grant's video, he talks about how really after years of teaching, he's determined, and I agree, that kind of the most efficient method for this is kind of a guess and check method. And although I do agree with that, I know some people don't love that. So I'm going to show you how you can do this more kind of algorithmically, although it is kind of more of a pain in the butt. So the way we typically do this, still using the diamond method in effect, is we're looking for numbers now, instead of that multiply to 2 and add to 7, we want numbers that multiply to a times c. So a times c is 2 times 3, which is 6. And our b is 7. So we're looking for numbers that multiply to 6. And I'm going to put the multiply on the bottom and add it to 7. Those numbers are 1 and 6. And here's the deal. There's an additional step that we need to do. This does not factor as x plus 1 times x plus 6. I just want to point out x plus 1 times x plus 6 definitely doesn't equal that. If you FOIL this out, you get x times x, you get x times 6, you get 1 times x, you get 1 times 6. You get x squared plus 7x plus 6. Definitely not 2x squared plus 7x plus 3. So here's what we have to do. We're going to use these numbers to rewrite the middle term as the sum of these two numbers. So we're going to write this as 2x squared plus, it doesn't actually matter which one you write first, whether it's 1 times x or 6 times x. I'm going to do 1 times x plus 6 times x plus 3. Now, you also need to have already watched Grant's video because you have to have watched the part on factoring by grouping to do this next part. So then we're going to, and this should always work, we're going to factor by grouping. So if you can find numbers that multiply to a times c and add up to b, this next step should always work. The first two pieces, the greatest common factor is x. We're left with a 2 times x plus 1. The next two pieces, the greatest common factor is 3, and the leftovers should be the same. We're also left with a 2x plus 1. Then we can factor out the 2x plus 1 from each of these, and write this as 2x plus 1 multiplied by x plus 3, which is the same result that Grant got when he factored it, just using a different process. So this process always works, but it's not always easy. So we're going to apply it here. So in this case, a times c is 5 times 6, which is 30, and our b is negative 17. So we're looking for numbers that multiply to 30 and add up to negative 17. Something to keep in mind, if you multiply to a positive number, the numbers have to be the same sign, either both positive or both negative. If you add up to a negative number, they both should be negative. If you add to a positive number, they both should be positive. So here we're looking for two numbers that multiply to 30 and add to negative 17. So our choices would be negative 1 and negative 30. Nope. Negative 2 and negative 15. Oh, there we go. Negative 2 and negative 15. So then we're going to rewrite this as 5x squared. Instead of minus 17x, we're going to write minus 15x minus 2x plus 6. Or you can write the minus 2x first and the minus 15x second. It doesn't matter. It'll work out either way. And then we factor by grouping. This first, oh, I didn't do this here. This first piece, we can factor out the greatest common factor of 5x. We're left with x minus 3. Now here we have to be careful because we could factor out a 2, but that's going to leave with a negative x plus 3. We want to make a factoring choice here that's going to leave us with the same leftovers. So we're going to factor out a negative 2, which leaves us with an x minus 3. Then each of these two pieces has an x minus 3 to factor out. So we get x minus 3 times 5x minus 2. I did it again where I didn't write the little bracelet there. Okay, here's our answer here. Now I should point out, this method works as long as the trinomial is factorable. Not every trinomial can be factored, but for the ones that can, you can do this, or you can do the guess and check kind of method, or something else that you might have learned before. Same idea here. A times c is 4 times negative 6, which is negative 24, and B is 5. So we're looking for numbers that multiply to -24 and add up to 5. So numbers that multiply to a negative, you have to have one positive and one negative. And if they're adding up to a positive, the positive one should be larger. So we're thinking something like 24 and -1. Nope, that adds up to 23. Or 12 and -2. That adds up to 10. Or 8 and -3. That adds up to 5. Oh, there we go. Again, this is not x plus 8 times x minus 3. This is 4x squared. You can either do plus 8x or minus x. Plus 8x kind of feels like the better choice, but I would argue that if you have the choice between doing a negative and a positive first, do the negative one first. This would be minus 3x plus 8x minus 24. So again, factoring by grouping, here we can pull out an x, and we're left with a 4x minus 3. Here we can pull out an 8. That seems wrong. I'm going to stop myself before I make a mistake here. I pulled out, see, a minus 3x, a plus 8. Oh, that's a minus 6, not a minus 24. That's the problem. Sorry about that. It's a minus 6. Don't make the mistakes like I'm making here. So then so what I saw was going to happen was I was going to have an 8x minus 24. I was going to factor out an 8, and then we left with an x minus 3, which isn't 4x minus 3. So here, if it's 8x minus 6, my greatest common factor is 2, and I'm left with a 4x minus 3. And then we can factor out the 4x minus 3 from each term and get 4x minus 3 times x plus 2. And I will show you here that it doesn't matter which order you write the negative 3x and the 8x, or whatever the two middle things are. If instead we had written it as 4x squared plus 8x minus 3x minus 6, not 24, then we're going to, again, factor by grouping. So now the greatest common factor from 4x squared plus 8x is 4x. And we're left with x plus 2. Here, the greatest common factor is 3, but I'm going to do negative 3 so that I get the same leftovers. So we get negative 3 times x plus 2. And then I can factor out the x plus 2. I'm left with x plus 2 times 4x minus 3. Same either way you do it. So it really, really, really doesn't matter which order you write the 8x and the negative 3x. Okay, let's do a few more. And again, these are all the same ones that Grant already did. I'm just showing you a different way to do them. So these next few are going to get a little bit gnarly though because the numbers get kind of big. So here, a times c is 8 times negative 10, which is negative 80. And my b is negative 11. So I'm looking for numbers that add up to negative 11 and multiply to negative 80. So again, I have to have one positive, one negative, but here, since they're adding up to a negative number, the negative one should be larger. So I could think of, and I really just start from the beginning. I'm going to start, so 1 and negative 80, that's negative 39, or 2 and negative 40, that adds up to negative 38. 3 is not a factor, 4 and negative 20 adds up to negative 16, getting closer. 5 and negative 16 adds up to negative 11. So then I can rewrite this as 8x squared and take your pick. Either write the negative 16x first or the plus 5x. I'm going to do the negative 16x first. Because I would rather leave, if there's a positive one, I'd rather leave that for my second term. Or the second piece. So again, right, this is the same. Negative 16x plus 5x is negative 11x. And then we can factor by grouping. This is going to be factor out an 8x, you're left with x minus 2. Factor out a 5, you're left with x minus 2. So then factor out the x minus 2, and you're left with an 8x here, plus a 5 here. Same process. You should try this next one the same way before I do it. Pause the video, give it a try. I'll point out that 6 times negative 12 is negative 72, but give it a shot. And now that you've given it a shot, let's try it. So a times c is 6 times negative 12, which is negative 72. And b is equal to negative 1. So we could go through the usual process of finding out adds negative 1 and multiplies negative 72. But I know that 8 times 9 is 72. And if one of them is negative, they're going to differ by 1. So I think I want the bigger negative. So I want a negative 9 and a positive 8. So we're going to rewrite this as 6x squared. I'm going to do the minus 9x plus 8x. That does add up to negative 1x minus 12. Factor by grouping. Factor out of 3x here. You're left with a 2x minus 3. Factor out of 4 here. You're left with a 2x minus 3. The leftover pieces have to be the same every time. You're left with 2x minus 3 times 3x plus 4. Cool. All right, this last one is going to be a little bit rough. So A times C is 100 times 17, which is 1700. Fortunately, 17 is a prime number, so this won't have too many terrible factors to deal with. And then B is negative 180. So we're trying to multiply to a positive and add them to a negative, so we have to have both things being negative. So we have, right, we're adding up to negative 180, we're multiplying to 1700. So here's some silly choices. 1 times 7, sorry, negative 1, negative 1700, or negative 2 times negative 850, or negative 4 times half of 850 is negative 425. Those still don't add up to negative 180. Um, negative 5 times, I think it's negative 340. That multiplies to that, but adds up to still too big, right? So we're way too big, right? Or way too negative. I think the next possible choice, I don't think 6 or 7, 8 is not a factor. Yeah, the next factor is negative 10, which I probably should have tried first, because negative 10 times negative 170 multiplies to 1700 and does add up to negative 180. So we're going to rewrite this as 100x squared. I don't really care which one I write first. I feel like the negative 170 makes more sense to go with the 17. So I'm going to write this as negative 10x minus 170x plus 17. And then we're going to factor by grouping. The greatest common factor here is 10x. We're left with a 10x minus 1. The greatest common factor here is 17, but we're going to do negative 17. So it's a negative 17 times positive 10x minus 1. Factor out the 10x minus 1, and you're left with the 10x here minus the 17 here. So that is an alternative way of trying to factor trinomials that have a leading coefficient that's different than 1. Yeah. All right. Good luck with that. Definitely do watch. You should have already watched before watching this, the video that I posted already that was made by Grant, which shows you all the kinds of factoring you might do. And yeah, I'll see you all in class tomorrow.